Hi students, welcome to physics classes. Now I am going to discuss expected 8 mark questions in 10th class public exam. Expected 8 mark questions, which are most important questions. Now these are important for 8 marks as well as for 4 marks. You will get 3 8 mark questions in the public exam. 3 8 mark questions. 2 questions will be in choice, internal choice, no? 1 or 2, any one you should write. Third question you will get choice with chemistry. So one question definitely you can write. From these two, any one you can write. If physics easy, physics you can write. Chemistry easy, chemistry you can write. And you will get 1 4 mark question in the public exam. 4 mark question 1, 8 mark questions 3. From that, for that 4 questions you should learn many of the activities. Okay, just you see. Now in the first chapter, heat. In heat we have activities. Heat we have activities. In that first activity number 4. Activity number 4, write an activity to show heat travel from higher temperature to lower temperature. Heat travel from higher temperature to the lower temperature. Important activity, very important activity. Heat travel from higher temperature to the lower temperature. Write an activity. Now that activity I already explained in the previous classes. Now I am not going to explain. If you see playlist, you will get a heat chapter. In that this activity will be. Now for this activity you should draw the diagram. Bottom we will take water, upon that we will pour coconut oil. We will place one thermometer in coconut oil, another thermometer in water. So heat water is hot water, coconut oil is room temperature. Now heat will be flowing, and readings in the thermometer I will take A and B. B will be decreases, A will be increases. You should write procedure and observation with the result. Okay, now sometimes they are asking this question for 1 mark question also. Like they will give this diagram in the given activity. Which thermometer readings are increases? Which thermometer readings are increases? A increases, coconut oil. You should observe A, B, not A and B. They will give you differently. This one they can give you A. This one they can give you B. So which is placed in water, mercury level decreases. Which is placed in coconut oil, mercury level increases. Okay, this is very important activity. Once you should see. Now next activity, second question, activity 5. Activity 5. Here they will ask question like this. Rate of rise in temperature depends on nature of the material. Rate of rise in temperature depends on nature of the material or substance. This activity. Now when they ask this activity, activity 5, we should take vessel filled with hot water, and we will take 2 test tubes. One is having coconut oil at room temperature, another one is water at room temperature. We will place 2 thermometers in that, and as a heat we are giving equally, but the thermometer which is placed in coconut oil, readings will be increases fastly. Which is placed in water, readings increases slowly. So even we given heat same for both the water and coconut oil. Coconut oil temperature is increasing fastly, water temperature is increasing slowly. So rate of rise in temperature depends upon the nature of substance. Next, write an activity to derive the formula for specific heat. To derive the formula for specific heat, here we will take two different masses. First we will take two different masses. One is having less mass, another one is having more mass. Now I want to raise both the temperature by 60 degrees Celsius. Both are at initial temperature, room temperature. Now I want to raise its temperature by 60 degrees Celsius, its temperature by 60 degrees Celsius, for which I should give more amount of heat for this body. So amount of heat given to a body depends on its mass when temperature is constant. Next, if I take two same bodies, two same masses, both are smaller. Now I want to raise its temperature by 60 degrees Celsius, its temperature by 80 degrees Celsius, for which I should give more amount of heat, obviously second one, more temperature. So amount of heat directly proportional to change in temperature. So while combining these two equations, we can write Q is directly proportional to m delta T. To remove this proportionality symbol, we will take one constant, that is specific heat, Q equal to ms delta T. So S equal to Q by m delta T. SI unit of specific heat, joule per kg Kelvin. CGS unit, calorie per gram degree Celsius. SI unit, joule per kg Kelvin. CGS unit, calorie per gram degree Celsius. This question not only for 8 marks, sometimes they'll ask you 4 marks, and it is very important in the form of short answer questions. They'll ask specific heat formula, they'll ask amount of heat formula, they'll ask units of specific heat, and here from this we can write Q means amount of heat, SI unit joule, CGS unit calorie. 1 calorie equal to 4.2 joules. 1 calorie equal to 4.2, nearly 4.2. We can write 4.186 also. Sometimes we will write 4.186. 4.2 also we can write. 1 calorie equal to 4.186 or 4.2 joules. Sometimes they will give you problem also based on these formulas. If they ask amount of heat Q equal to, if change in temperature, ms delta T. S means specific heat. Okay. Next question, determination of specific heat of a solid. Here this means lab activity, very important in the point of 8 mark questions. Specific heat of a solid. Here we are finding specific heat, that you should remember. Determination of specific heat of solids. Determination of specific heat of solids means here we are finding specific heat of a given solid material. Specific heat of a given solid material. Okay, in the textbook one material they given, in the exam they will ask whatever it is, given object specific heat we are finding. Here sometimes directly they are asking questions, sometimes they are asking twisted. For example, Mahesh wants to find specific heat, like that directly they won't give you. Mahesh wants to prepare a cooking vessel with a suitable material. Cooking vessel with a suitable material. He is having aluminum, silver, bronze, copper, steel, like the different materials they will give you. In these materials, he wants to prepare a cooking vessel with a suitable material. He wants to find which is suitable material from that. So suggest him a procedure and write experimental procedure to find which material is suitable for it. In the given question, they didn't ask anywhere about specific heat. The word specific heat they didn't use. He wants to prepare cooking vessel with suitable material. Suggest him best procedure to find which is suitable. So you should know cooking vessel should have less specific heat. Cooking vessel should have less specific heat. So we know application of specific heat. As water is having more specific heat, it is able to store more amount of heat. Even we given more amount of heat, its temperature will not rise quickly. Even we given more amount of heat, its temperature will not rise quickly. So because it is having more specific heat. So whenever any object has more specific heat, it won't raise its temperature quickly. So for example, if you use a material which has more specific heat, I'm saying more specific heat, you kept on the stove with a milk, water, whatever it is. First, it will take more time to heat. After it is getting heat, after its temperature is raised, that heat is transferred to inside, right? So here, if it takes more time, how it will transfer heat inside quickly? So it should have less specific heat and it should take less time to raise its temperature. Immediately, if you keep on the stove, you should get more temperature. Then it transferred to inside. Then water, whatever it is, we keep inside, will get heat, temperature more. So cooking vessels should have less specific heat. That you should know. Here he wants to find which material is suitable, best material that should have less specific heat. So he wants to find specific heat. Okay, so forget about all these materials, whatever they given. In that, you should decide we should find specific heat. You should go to lab activity. Okay, very important. Next question, activity 8, evaporation. Very, very, very important question. Evaporation. Evaporation means changing from liquid to gas at any temperature below the boiling point. So they will ask you what are the factors affecting the evaporation. Explain with activity for each effect. Now here we are having evaporation depends on surface area, wind speed, humidity, change in temperature. Change in temperature. For all, we should learn one activity. Surface area, we should take two materials. One has more area, another one is less area. When we take surface area is differently, remaining three should be constant. Both should be at same place. Next, wind speed. We should take two materials, same materials. One is placed under the fan, another one is in the cupboard. Humidity. One is inside of the room, one is if raining outside near the rain, more humidity. Change in temperature. One is placed under the sunlight, another one is placed in the closed room which has AC. So whenever we are taking, one is constant, one is changing. For example, you are taking surface area consideration, remaining three should be constant. Wind speed, remaining three should be constant. Humidity, remaining three should be constant. Okay, whenever you are observing one thing, that should be changed. Surface area should be changed. Wind speed, air, one place air should come, another place should not come. Humidity, one more humidity, one less humidity. Change in temperature, one is at more temperature, another one is at less temperature. That one only should change, remaining should be constant. One, if you take one is having less area, another one is having more area, and you are checking wind speed, wrong. Okay, whenever you are checking wind speed, surface area should be constant, humidity should be constant, temperature should be constant. That you should write. Very, very important. Simple activities. Okay, you will get 8 marks. Okay, these are the 8-mark questions from this lesson. These are the 8-mark questions from this lesson. One more important question. They will ask you problem. Which is in the textbook only, they will ask most of the times. You are having ice, 1 gram of ice, for example at minus 5 degrees Celsius. You want to convert it into 100 degrees Celsius of vapor. vapor at 100 degrees Celsius. Mass is same. Now first directly ice won't convert into vapor. First ice converts into ice minus 5 degrees Celsius to 0 degrees Celsius. Next ice 0 degrees Celsius to water 0 degrees Celsius. Next water 0 degrees Celsius to water 100 degrees Celsius. Next water at 100 degrees Celsius to vapor 100 degrees Celsius. This is Q1, Q2, Q3, Q4. All you should add. Here temperature changing, state should be constant. When temperature changes, state is constant. You should use specific heat. Q equal to ms delta T. Yes, specific heat of ice 1/2 calorie per gram degree Celsius. Mass 1, they given. Change in temperature minus 5 to 0, 5 degrees Celsius. Next, ice at 0 degrees Celsius to water at 0 degrees Celsius. State is changing, temperature is constant. Latent heat, Q equal to ml. Latent heat of ice 80 calorie per grams. Next, water at 0 degrees Celsius to water at 100 degrees Celsius. Temperature changing, ms delta T. Yes, specific heat of water 1 calorie per gram degree Celsius. Change in temperature 100, mass 1 gram. Now water at 100 degrees Celsius to vapor at 100 degrees Celsius. Temperature is not changing, state is changing. Q equal to ml. Latent heat of vapor 540 calorie per grams. Mass 1 gram. All you should add finally. Okay, important. Next, sometimes they are asking differences between evaporation and boiling. Differences between evaporation and boiling. Now whenever they ask differences between evaporation and boiling, first you should write the definition. Both definitions. Evaporation, change of liquid state to gas state and any temperature below the boiling point. Boiling, at a boiling point, changes from liquid state to gas at a boiling point. At boiling point is for water 100 degree Celsius. Okay, evaporation is a cooling process. Evaporation is a cooling process. Boiling is not a cooling process. Evaporation, surface phenomena. Means surface liquid at the surface will be evaporates first, then remaining will be. Now here boiling is bulk phenomena. After completing all the water at 100 degrees Celsius, it starts boiling. So it is bulk phenomena. It is surface phenomena. Okay, it takes place at any temperature. It takes place at a particular temperature, constant temperature. Very, very important for 4 marks. Okay, next, sometimes they are asking differences between evaporation and condensation. Differences between evaporation and condensation. Same, evaporation definition, condensation definition. Cooling process, condensation is a warming process. Evaporation, cooling process, condensation, warming process. Very, very important. Bits, sometimes they'll ask you in the bits also. Okay, evaporation, state changes from liquid to gas. Here gas to liquid. Okay, that you should write. Very, very important questions from the heat lesson. In the now we will discuss about plane surfaces. Refraction of light at plane surfaces. Plane surfaces, in that first we should learn about refractive index. Refractive index, they won't ask for 8 marks. Sometimes they can ask for 4 marks. Refractive index definition, formula, units. And you should write refractive index is not having any units. No units for refractive index. Why it is not having any units? Very, very important. It is the ratio of two same physical quantities. Formula n equal to c by v. C means speed of light in vacuum, speed. V means speed of light in any medium, speed. Both are same quantity, speed, meter per second. Both gets cancelled. So refractive index has no units. Sometimes they'll ask why refractive index has no units. Give the reason. Refractive index is the ratio of two same physical quantities, so no units. Okay, you should write refractive index, formula, definition. Now lab activity, which is very, very, very important question. Lab activity, sometimes they will ask you question directly. Sin I by sin R equal to constant. Write an activity to show sin I by sin R equal to constant. Or sometimes they will ask you what is the relation between angle of incidence and angle of refraction when light ray traveling from rarer medium to denser medium. And sometimes they'll ask you why angle of incidence is more than angle of refraction when light ray traveling from rarer medium to denser medium. Angle of incidence is more than angle of refraction when light ray traveling from rarer medium to denser medium. Write an activity for these, all very important. Okay, we'll take a semicircular glass disc. That activity you should write. You should write the preparation of pro circle also, not completely, at least you should give brief. We should take a white paper, we should draw the horizontal line, vertical line acts as a normal NN, horizontal line is a interface MM. We should have the readings. By using protractor we can draw the readings from 0 to 90 to 0, 90 to 0. Okay, on that we should place the semicircular glass disc. We should send the light ray from rarer medium to denser medium, and we should find the angle of refraction. We should find sin I, sin R, and we should find it is constant. If they asked the relation, means directly we can write. If they asked here angle of incidence is greater than angle of refraction, means you should write the conclusion by seeing the table. You should draw the empty table there. I, R, sin I, sin R, sin I by sin R. Now in the table, by using the table, we can say angle of incidence is always greater than angle of refraction when light ray traveling from rarer medium to denser medium. Very important. Okay, in this lesson, first preference this question. Sometimes they will ask you, write an activity to show Snell's law. Write an activity to show Snell's law. What is Snell's law? N1 sin I equal to N2 sin R. Same activity we should write. Sin I by sin R equal to constant. Constant is equal to refractive index of the semicircular glass disc. So we can write refractive index N2 by N1 sin I by sin R equal to N2 by N1 cross multiplication N1 sin I equal to N2 sin R. Okay. Now next activity 4. In the plane surfaces, activity 4. Now here also relation between angle of incidence and angle of refraction, but light ray traveling from denser medium to rarer medium. Write an activity to show that angle of incidence is less than angle of refraction when light ray traveling from denser medium to rarer medium. Like that they will ask the questions. Now here we will take a glass disc, glass pro circle or plastic pro circle. We will take two straws, one is down, another one is up. We will place in the vessel of water, transparent vessel, and bottom one is fixed. By seeing bottom one, top one will place straightly. Now if you take it outside, both are not straight. So light ray here traveling from denser to rarer, angle of incidence is less than angle of refraction. Here also you should draw the empty table, and if they ask relation, by seeing the above activity we can say the relation that angle of incidence is greater than angle of incidence is less than angle of refraction. If they ask directly here, we can write by seeing the table, we can say angle of incidence is less than angle of refraction. This is also very important, second preference in this lesson. Next question, total internal reflection. Total internal reflection, 8 marks they can ask, 4 marks they can ask, 2 marks they can ask, even 1 mark also they can ask. This many possibilities are there. If they ask 8 marks, they will ask you 2 activities, 4 marks 1 activity, 2 marks definition, 1 mark based on these formulas are there. In total internal reflection, we should learn about critical angle also. Critical angle, light ray sending from denser medium to rarer medium at one particular angle of incidence, angle of refraction equal to 90 degrees. Like that we can say, or at particular angle of incidence, light ray grazes at the interface. When light ray traveling from denser medium to rarer medium at one particular angle of incidence, light ray grazes at the interface. That angle of incidence is known as critical angle. At that situation, angle of refraction is 90 degrees. If angle of incidence is more than critical angle, light ray reflect into the same medium, that is known as total internal reflection. Here also we should mention that light ray traveling from denser medium to rarer medium, angle of incidence is more than critical angle, then light ray reflects into same medium, total internal reflection. Here we are having two activities for this. One is a glass disc activity. We should send from top onwards at a particular angle of incidence, it will be reflects. And another one is we should take a vessel which is filled with water. We should keep a hole, water is coming out. When we focus a laser light at this point, straightly falling onto the hole, and light ray will not refract, it will not come out. In this path only it will be reflects. That is also total internal reflection. Very, very important. Here in the point of beats, what is the relation between critical angle and refractive index? Critical angle, sin C equal to 1 by refractive index, or refractive index equal to 1 by sin C. Refractive index, okay. Now sometimes they will ask you what is the relation between critical angle and refractive index. Most of the students getting difficulty here, they know this formula, they'll get confused and writing critical angle definition and refractive index definition separately. They are writing critical angle definition and refractive index definitions separately. Okay, not like that. If they ask relation between them, relation you should write. Okay. Sometimes they are asking which refractive index it is. Which refractive index it is? Refractive index of first medium. As we are sending light ray from denser to rarer, refractive index of first medium with respect to second medium. Refractive index of denser medium with respect to rarer medium. Most of the times we are taking air, so refractive index of air is 1, so we are considering refractive index n. Remember that refractive index n12, sin C equal to 1 by n12. Okay, if they given in the matchings, don't get confused. Sin C equal to 1 by n12, 1 by n12. If they given sin C equal to n21, it is also correct. n21, as we know, n21 equal to 1 by n12, relative refractive index, bits. Okay. Next one is mirages. They are asking 4 marks and 8 marks. As here we are getting difficulty. What is this is the first time they are giving this pattern. So which question they are asking for 8 marks, which question they are asking for 4 marks, we can't decide perfectly. So all 8 mark questions can be asked like 4 mark questions, and even 4 mark question also can be asked for 8 marks. So all you should learn, then you can get good marks. Mirages, it is an example for total internal reflection. It is a optical illusion. When you are traveling in the highway roads, at some distance you will find water. When we go there is no water. Okay, sometimes question also asked like this. They won't ask mirage. Krishna is going in the vehicle on the highway roads. At some distant point he is find some water on the road. When he go there is no water. What is the situation, is what phenomena he observed there, what we can call it, why it is. Okay, that is mirage. You should explain mirage question. Here one important question. A mirage is an example for change in the refractive index in a particular medium. If you take air, generally refractive index is a constant, just we discussed. Now here if you take air, because of the change in temperature, refractive index also changed here. Refractive index decreases with the depth, or it is increasing with height. As we go up height, refractive index is increasing in the air itself. So light ray takes total internal reflection and it appears like a water. Light which is coming from the tall object appears like a water on the road. Very important. This is also example for total internal reflection. Mirage is also example for total internal reflection. Next, applications of total internal reflection. 2 applications are there. Brilliance of the diamond and another one is optical fibers. These are the two applications that also you should learn. Very important for 2 marks questions. Next topic, refraction of light at curved surfaces. In the curved surfaces, we have few questions for 8 or 4 marks. Few questions. One is very important question, ray diagrams. Very important question, ray diagrams. You should learn all rules to draw ray diagrams. Rules to draw ray diagrams, followed by you should learn ray diagrams also, mainly for biconvex lens. Biconvex lens, rules to draw ray diagrams and ray diagrams for biconvex lens. Next, one important activity is there in this lesson. Focal length of the lens changes with the surrounding medium. Focal length of the lens changes with the surrounding medium. We will take a vessel containing water. We will place the stone at the bottom of the black stone at bottom of the vessel. We will take the lens with the help of holder, and the lens focal length we know. And first we will place at some height and we will increase up to certain height. Slowly we will increase. At a particular point we can't see, and we know the focal length of the lens in air. So at that height if you place, generally by using convex lens we can see the object through the lens. When we are able to see through the lens, when the object is between pole, optic center or pole and focus. Between pole and focus, if object is placed, directly we can see, because it forms virtual image. When the object is placed between pole and focus, we can see directly through the lens, because it forms virtual image. So here, as we are increasing slowly, if we are seeing the stone means that is placed between pole and focus. If its length is more than focus, we can't see. So at a particular height we are able to see that height is more than focal length of the lens in air. So focal length of the lens is increased in the air, in the water. So when medium is changed, focal length of the lens also changes. Focal length of the lens depends on surrounding medium. Once you read this activity from the textbook, very important. And in this chapter, lens formula, lens maker's formula, and the terms, lens formula, lens maker formula, and the terms, very important. Okay. Next chapter, human eye and colorful world. Human eye and colorful world. In this lesson, defects of human eye: myopia, hypermetropia, are very important questions. Myopia, if they ask myopia, they won't ask directly. Sometimes the person is able to read the letters on the newspaper, but he is not able to read letters on the names on the name boards, which are shopping malls names, bus names. He is unable to read, but he can able to read newspaper. Like that they can ask. Or sometimes they are asked, Pawan is a student. When he sit in the last bench, he is unable to read the letters on the blackboard, but he is able to read letters on the textbook. What defect he is having, what is the correction, explain with the help of diagrams. Myopia means nearsightedness, the person who is able to see near objects and cannot see far objects. Nearsightedness, can see near objects, cannot see far objects. He is having far point, maximum distance at which eye lens can form image on the retina. The definition. Other name, Myopia also known as nearsightedness. And what is the focal length of this person? Generally, healthy person can see from 25 centimeters to maximum all distances, but this person can see particular distance. After that he can't see. This up to where he can see, that is known as far point. Okay, now what is the focal length of this person? Generally, healthy person minimum focal length is 2.27 centimeters, maximum focal length is 2.5 centimeters. He is having minimum focal length correctly, maximum focal length is less than 2.5 centimeters. Less than 2.5 centimeters. Okay, now what is he should use biconcave lens, and correction also you should explain with the help of diagrams. Hypermetropia, reverse. He cannot see near objects, can see far objects, far-sightedness. Now the person, he is not able to read letters on the notebook, can read, but he can read letters on the blackboard. Reverse, previous case reverse. So he is having hypermetropia. He is having near point definition, minimum distance at which eye lens can form image on the retina, and he is having minimum focal length is more than 2.27. Minimum focal length is more than 2.27 centimeters. We should use biconvex lens to correct the defect hypermetropia, and we should explain with the help of diagrams. Okay, very important questions. Next, rainbow. Next option, rainbow. What is rainbow? How it is formed? Natural spectrum. Okay, explain the natural rainbow. Like that they'll ask questions. Okay, it is explained in the videos. Once you go through that, all classes I explained, all topics I explained. Once you see this, at that angles you should remember 40 degrees to 42 degrees. Okay, here what are the phenomena involved? Refraction, dispersion, total internal reflection. These are important words which to be mentioned clearly. Next, scattering of light. In this chapter, scattering of light. In that, very important question is blue color of the sky, white color of the sky, and why sun appears red in the evening and morning, white in afternoon. That because of scattering. If atmosphere consists of more number of nitrogen or oxygen molecules, they'll absorb blue color light and emits into all the direction. So blue sky appears in blue color. Nitrogen and oxygen molecule size is comparable to blue color wavelength. So blue color is absorbed and re-emits into all the directions. So sky appears in blue color. White color, when it appears, water molecules. When water molecules are present, water molecule is able to absorb all colors except blue. So sky appears in white color. All colors, combination of all colors is white. Next, why red color? Sun appears red color. These two, sky. Blue color, white color, sky. This red color is sun. Morning time, evening time, sun appears red color. Afternoon, white color. As sunlight traveling, morning time, evening time, sun rays to travel more distance. So when it is traveling, all colors means white color, all colors are coming. But in the atmosphere, molecules are present, no? The molecules which are able to absorb red color are less in the evening and morning. So red color is not absorbed, remaining colors are absorbed. So red color is reaching to our eyes. So it appears in red. Afternoon time, it is traveling less distance. All colors equally absorbed and re-emitted. So all colors will reach us to our eyes. So it appears in white color. Very important questions. Next chapter, electric current. In the electric current, many important questions are there. Everyone should read compulsory. First question, Lorentz and Drude and Lorentz experiment, electric current. They explained about electric current, open conductor, closed conductor, how it is they explained clearly, they explained, and in the video also I explained clearly open conductor what it is there, closed conductor what it is there, closed in the sense connected to the battery. Okay, both you should explain clearly, and you should draw the diagrams for both open conductor diagram, closed conductor diagram. Finally you should derive I equal to q by t with that formula also, 1 ampere equal to 1 coulomb by 1 second. Very important question, electric current. Next, Ohm's law. Ohm's law with the diagram we should explain. Whenever they ask Ohm's law, we should write which obeys the Ohm's law. First activity enough. Okay, you should draw the diagram and you should draw the graph also. You should draw the empty table. V by I equal to constant. V equal to IR formula. Finally, you should write V equal to IR formula, and R equal to V by I. R V potential difference, volts, I current, amperes, R resistance, ohms. That all you should write. Sometimes they will ask you limitations for Ohm's law. Which obeys the Ohm's law are ohmic materials, which do not obeys the Ohm's law are non-ohmic conductors. Okay, that is the limitation. Some materials will not obey the Ohm's law. If you do the same activity for that, we will get the graph indifferently. Here straight line, V by I is straight line. Here V by I, VI graph is not straight line. VI graph is straight line. VI graph is not straight line. Remember that. Okay, which do not obey Ohm's law are called non-ohmic materials. Some materials will not obey. Example, gaseous conductors and semiconductors. Example, silicon, germanium will not obey the Ohm's law. Okay, very important question. Next, electric shock. Electric shock, while writing electric shock question, in the textbook they given 2 examples. When we touch 24 volts wire, what will be happen? 240 volts wire, what will happen? At the time our resistance is 1 lakh, here also 1 lakh. Now what is the current entering into our body? From that onwards you should start. Okay, current enter into our body. First what happened, next what happened, and finally you should write. Okay, it is the combined effect of potential difference and electric current and the resistance of our body. Combined effect of resistance, electric current, potential difference. Very important. This should be mentioned compulsory. Next, definition of resistance. Resistance depends on some factors. Factors affecting resistance. Directly they are asking. Temperature, not much, but length and the area of cross section much. Resistance and directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. And combinedly we are writing R equal to rho L by A. Rho is the proportionality constant, specific resistance, resistivity, rho equal to RA by L. R ohms, units, resistance units ohms, and resistivity units ohm meters. Okay, based on this problem also they will ask sometime these 2 formulas. Based on these 2 formulas they will ask problems, or sometimes they will ask directly this derivation. Okay, you have resistance affecting factors affecting resistance are first temperature activity, length activity, area activity, area of cross section, and nature of the material. Okay, these activities once you should learn compulsory. This is most, these 2 activities most. They are asking sometimes write an activity to show that the resistance of the conductor depends on length of the material when it is having constant cross sectional area and temperature. Like that they will ask. Remember that they asked activity for length and they mentioned area is constant. Some of the students are getting a confusion and writing both activities. Remember, if they ask length, area is constant, that we know. They will mention in the question area is constant. You should read the question carefully what they asked. Okay. Next, series, very important. Parallel. Very, very important. In series, current is constant, same, not constant, same for all the materials. Potential difference is changing. V equal to V1 plus V2 plus V3. From that we will use Ohm's law. V equal to IR, and we will derive R equivalent equal to R1 plus R2 plus R3. For parallel, reverse it. V is constant. I is dividing. I equal to I1 plus I2 plus I3. So V equal to IR, I equal to V by R, and we'll substitute there. I1 equal to V by R1, I2 equal to V by R2, I3 equal to V by R3. We'll substitute there, and finally we'll get relation 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. And remember, they won't ask, sometimes they won't ask directly series and parallel. Series is end-to-end connection. Resistors. Diagram they will give you and ask something. Parallel, all ends connected together. All positives, all negatives, all positives are connected, all negatives are connected. Like this. Okay. Equivalent resistance is the sum of individual resistances. Okay, this is reciprocals of resistances. Very important questions. Based on these problems also they will ask. One problem we'll discuss. Now 2 ohms, 3 ohms, 4 ohms resistors are connected in series. Connected in series, what is the equivalent? Sum. Directly we can do the sum. 2 plus 3, 5 plus 4, 9 ohms. If they ask for parallel, 1 by 2 plus 1 by 3 plus 1 by 4. LCM, that is also for 1 by R equivalent, remember. Now if you take the LCM, we can take 12. Here 6 times, here 4 times, here 3 times. 10 plus 13 by 12. That is for 1 by R equivalent, remember. Then R equivalent equal to 12 by 13 ohms. Okay. Should read the question carefully, and while writing answers, focus on the answer. You are doing addition or subtraction, whatever it is, whenever they given problems, you should focus on the answer. Okay, step by step you should write clearly. Next, sometimes they are asking junction law. We can write sum of currents entering into the junction is equal to sum of currents leaving from the junction. This is the point junction. So I1 is entering, I2 is entering, I3 is leaving, I4 is leaving. So I1 plus I2 equal to I3 plus I4. Sum of currents entering equal to sum of currents leaving. Or algebraic current, sum of currents in any junction equal to 0. So I3 is coming this side minus, I4 coming this side minus, equal to 0. Remember that, students, whatever the diagram you draw, that for that only you should write the equation. Some of the students are writing equation directly from the textbook, drawing their own diagrams. Based on the diagram you should write the equation. This is electric current. Next, electromagnetism. In electromagnetism, Oersted experiment. Based on Oersted experiment, we have 3 activities. Another, first, Oersted experiment, current carrying wire producing magnetic field. Current carrying wire produces magnetic field. Write an activity to show that current carrying wire produces magnetic field. Like that, if they asked, you should write Oersted experiment. And straight wire carrying current, circular coil, solenoid. Activities are there, just you refer it. Okay, if they mention that activities, you should write. Next, in this question, in this chapter, magnetic flux density. Magnetic flux density. Okay, and their relation, B equal to phi by A or pi equal to BA. And here Another important questions, motor is DC electric motor, and a generator. We have AC generator, DC generator. Motor, they will ask, explain the working of a device which converts electrical energy to mechanical energy. Here mechanical energy to electrical energy. Diagrams very very important. Question carefully you should see. Confusion. Sometimes DC motor they ask, the students are writing generator. Okay, clearly electrical energy to mechanical. Current we are giving, it will rotate. Example, fan. Current we are giving, it is rotating. Electrical energy giving, mechanical energy coming. Generator, which generates electric current. Remember like this. We will rotate it, electricity is coming. Okay, dynamo. Example, dynamo. Okay, these questions will be asked. And here some formulas are there, which is important. Force equal to QVB. Force equal to BIL. Force, electromagnetic force. Q charge, V velocity of charge, and B magnetic field. Magnetic field, electric current, length of the conductor, force. These relations also very very important. These are the most important 8 marks and 4 mark questions in the physics. Thank you for watching. Please subscribe.